Good afternoon, my two viewers. Crystal here. I'm just here to make you another video of some more work that I've done. I hope that the quality of the video is okay. I've got a new Chromebook, but for some reason, the quality of the sound isn't very good. I just have it to where voice comes up as it records my voice, but it still picks up other things as well. So I do apologize for that. In the new year, I'm going to be getting a new computer, and hopefully the sound on that computer will be better. So the first thing I wanted to say is that I've put my file that I have on a Github account. I've put that on NB Viewer, and this is the, I just got it here. This is the number of the file. If you want to type that in, then that will give you the number of the file. What I might do here is I'll copy the file and I'll put it in the description. And that way you can go into NB Viewer and you can call it up yourself. And that way you won't type it in by hand, because I've noticed that whenever I type things in by hand, I always have typographical errors and I have to go back and change them. Now this is the file that relates to the blog post that I wrote. So you can always go into the file on NB Viewer and follow along with me. The first thing we're going to do is we're going to talk about the problem statement. This is an analytics vidhaya Janetta hack problem. It says company of Electrolysia supplies electricity to the city. It is looking to optimize its electricity production based on the historical electricity consumption of the people of Electrovania. The company has hired you as the data scientist to investigate the past consumption and the weather information to come up with a model that catches the trend as accurately as possible. You have to keep in mind that there are many factors that affect electricity consumption, and not all can be measured. Electrolysia has provided you with this data on hourly data spanning 5 years. For this competition, the training set is comprised of the first 23 days of each month, and the test set is in the 24th to the end of the month, where the public leaderboard is based on the first 2 days of test, whereas the private leaderboard considers the rest of the days. Your task is to predict the electricity consumption on hourly basis. So that's your problem statement. It's supposed to be a time series analysis, but one thing that's peculiar about this time series analysis is because you have the first 23 days of the month and the training set, and then the last of the month in the test set. So that makes it a bit awkward. So in some ways, it makes it a bit difficult as a training set or as a time series analysis, but that's what they say it is. They say it's a time series analysis. So the first thing I did was I imported my libraries. And I imported my files are on my GitHub account. So if you go into Tracy Renee 61 Electrolysia, then you'll be able to find my files. And then that way you can either download them from the Analytics Vidhaya website if you like, or you can use the websites that I've got on GitHub. This is your train file. You see it has date, time, temperature, var1, pressure, wind speed, var2, electricity consumption. And then we have a test file, which is everything except electricity consumption. Then we have a sample. This is what Analytics VidHaya wants to see when you submit your submission. What we did was we tested for any null values in the train test and the test set, and goodness, there were no null values, so that means we didn't have anything to impute. The next thing we did was we want to convert the date time to year, month, day, and time. So we created a column called year, and we extracted the year from date time. We created a column called month, and we extracted the month from date time. We created a column called day, and we extracted the date from date time. And we created a column called time, and we extracted the time from date time. Now, what we did was we found out that var2 is an object column, and so before we can put this column into the model to be trained on, we have to convert it to a numeric column. So what we've done is we've used ordinal encoder, and so we've used ordinal encoder and we've reshaped it. So now here's what our train data set looks like, and everything is numeric, which is what the computer wants to see. But then we found out that this datetime file was actually a string, and when we created those 4 new columns and converted those to year, month, day, and time, that they were actually strings. So what we've had to do is we've had to convert those columns to integers. And now what we do is we define our x, y, and x test values. So the first thing that we did was we created a variable called test ID. And when we created this variable called test ID, created a variable called ID. And when we created this variable called ID, we put the contents of test ID in it. And the reason why is because when we created X and X test, we dropped the column that said ID, but we're still going to need the ID. So that's why we created this variable called ID. And then Y is train electricity consumption dot values. So Y is your dependent variables, and X test are your independent variables. So now what we did was we split our train set up for training and validation, and we're only using 10% of the train set for validation. Done is we made a pipeline. So model equals make pipeline standard scalar. So we put all of the variables or all of the independent variables into a standard scalar. And then we decided to use ADA boost regressor with the base estimator as random forest, random state 1, fit X train, Y train. And we print the model score X train, Y train, and we got a 98.71% accuracy on that, which is an improvement over the random forest alone. Now we created a variable called ypred equals model predict xval. Xval is your validation set. Print model score xval yval, and we've got an accuracy of 77.06%, which is about 3% increase over the last one, one random forest. And now what we did, we put this on the RMS, and we see what the root mean squared error is, and that's a 53.46. And so what you want is you want the error to be as low as possible. And I don't remember what the error was when we just used random forest, unfortunately. So then what we did was we put this on a data frame so you can compare the actual and the predicted values, and you can see how off the actual and the predicted values were to the actual values. And then what we did was we put these values on a chart and we plotted a chart. You can see that the predicted values are close to the actual values. Now what we've done is we predicted on the test set, which is X test, and we created our submission file, which is ID and electricity consumption. And you'll notice that the ID that we created up at the beginning of the program, we're taking that ID and using it in our submission now. And the electricity consumption is your prediction. And we've taken this data frame and we've converted it to a CSV file. And what we did was we have taken the CSV file, downloaded, and submitted it to Analytics VidHire. And when I submitted it to Analytics VidHire, I got a score of 85.95. And so that's about 9 percentage points better, or 9 points better than random forest alone. And it's not 9 points, 7 points better than random forest alone. And then it's about 7 points higher than the best score. So that's not too bad. That's pretty good. So that concludes it for this program.